friends, good morning everyone. This is the second lecture related to class 9 physics from 5th chapter, that is sound. And in this lecture, today we will discuss about the concept of characteristics of sound wave. In previous lecture number 1, we were studied what is the sound and how the sound travels in a medium. In that lecture, we will discuss that sound travels in a medium in the form of waves. Without medium, there is no chance of traveling, or you say that propagating of sound. And sound how produced? Sound always produced by vibrating objects or vibrating materials. Suppose we are speaking here, then there is a concept of vibration of vocal cords. And when the vocal cords vibration is going on, then we can speak or we can produce sound. So the next concept about sound, that is what? Characteristics. Important characteristics of sound waves. Let's see. In characteristics, total five characteristics, starting from wavelength number 1, wavelength number 2, amplitude, and number 3, time period, number 4, frequency, and number last, that is number 5th, speed or velocity. Here, for understanding about all characteristics of waves, or you say that sound waves, no matter, a important diagram concept. When you just understood about diagram, then everything will be clear. Let's see what is the diagram concept. Here, this is the graphical representation of transverse wave in the form of crest, and when you are just taking in the form of compression and rarefaction, then representing what? Longitudinal waves. Here, this is the representation of waves in the form of graph. Here, this is special notation lambda. Lambda here, the distance between two consecutive crests, or you say that distance between two consecutive, that is compression. Distance between two consecutive compression, or you say that distance between two consecutive crest. And this one, from this point to this point, this is what? Amplitude. Amplitude. And here, this line is normal density line. I will say that zero density line. Normal density line. And here greater density, and here minimum density. Whenever going on, then this is O, this is A and B, and here C. With the help of this diagram, we can define all the definitions, all the characteristics of sound wave. Number first, wavelength. Wavelength, the minimum distance. Listen about definition concept. The minimum distance in which the waves repeat their positions or repeats the situations of movement itself once. Suppose here the particle is in upward movement at this point, and here also the particle is in upward movement. It means in these two conditions the particle is in same phase. Particle is in same phase, and whenever the particle is in same phase, then the minimum distance between the two particles lies in same phase. That is what? Wavelength. Or in simple word, the distance between two consecutive crests or distance between two consecutive trough. This is the crest concept. This is crest. This is also crest, and this one is trough. So we can define the wavelength. In other words, let's see first definition. Wavelength the distance between two consecutive crests. The distance between two consecutive crests. The distance between two consecutive crests is defined as wavelength. It is denoted by symbol lambda. The unit of wavelength the SI unit of wavelength is meter. Clear? The SI unit of wavelength is meter, and then after wavelength, amplitude. Second one is amplitude. Very simple concept. In amplitude, the diagram concept, the maximum displacement of particle from its mean position, either in upward direction or in downward direction. Here this one is amplitude, this one also amplitude, and this one also amplitude. Clear? So concept of amplitude very easy. The maximum displacement of particle maximum displacement of particles here particles, that is medium particles, either in upward direction or in downward direction, either in upward direction or downward direction. Clear? This is amplitude, and this one also amplitude. So in any way we can represent. It is represented by small a. It is represented by a, and its unit also meter. Its unit also meter. Clear? And then third, that is time period. Time period see the time taken to complete one cycle. Complete one cycle, very easy. Suppose the particle whenever disturbed in the medium, then wave is going on, and wave here starting from this point and first, and then when come back in same position, just like after passing through A, and then when come back to B, then from O to B, the position of vibration of particles is same, that is in upward, here in upward. So the time taken to complete one cycle or one vibration in a medium, then that particular time is defined as what? Time period. The time taken to complete one cycle is defined as time period. Is defined as time period. Clear? And it is represented by capital T. It is represented by T. Its unit is second. Clear? So definition about time and time period and its unit also clear. And then last one is speed or velocity, not last. Number 4. Then after this will be last. Frequency. Frequency here, the number of complete oscillation in unit time. In unit time is defined as frequency. Very simple. The number of complete cycle, or you say that number of complete oscillations. The number of complete cycle, I will say that oscillation, no matter, in unit time, that is defined as frequency. Is defined as frequency. You see, the lower portion not visible here, and now time this one visible. Clear? Is defined as frequency. Its unit is hertz or second inverse. Hertz or second inverse, and is represented by nu or f. In some book that is represented by f, that is small f, and some book representing by nu, having v but somewhat amount bend from top. So all these 5 characteristics, very easy, very just one time revise, then everything will be clear. And then last one, that is 5th, what? Speed or velocity. It is defined as the distance. I will say that here distance means what? That is wavelength. The wavelength covered in given time interval. The wavelength covered in given time interval, whenever taken, then defined as speed. I will say that the time rate of change of distance. Time rate of change of distance is defined as speed. Very simple. The concept of definition. Let's see. here from this one region speed, the time rate of change of distance or displacement is defined as speed or velocity. Clear? The time rate of change of distance whenever taken, then speed, and when displacement taken, then velocity. And here in one complete oscillation, suppose starting from this point then up to this point, here this is if P and this one if Q, the distance between P and Q, that is wavelength lambda, and up to traveling this wavelength, if time taken is what? Time period, that is capital T, then speed, formula here, V is equal to what? Lambda upon T. V is equal to lambda upon T. Lambda means what? That is distance, or you say that displacement, and T means what? Time period to completing one oscillation. Suppose if they starting from P then up to Q, because at P the particles position in this situation and at Q also in this situation. So in between same phase, the distance traveled by particles, whenever the particle is in same phase, that is defined as wavelength. Suppose the point is at point O in this phase, and here also at point B in this phase. So in these two cases, either we can take here from A also in this phase and from C in this phase. The minimum distance between the particles in same phase, that is defined as what? Wavelength. And amplitude, maximum displacement of the particles vibration from mean position either in upward direction or in downward direction, that is amplitude. And here amplitude after then time period, the time taken to complete one oscillation or one cycle or one vibration, that is from O to B or from P to Q or from A to C. In any condition you can define the time period either from O to B or from P to Q or from A to C. Clear? Whenever particle is in same phase, then the time taken between two same phase situations, successive same phase situation, that is what defined as time period. And the frequency here, the number of complete cycle or oscillation in unit time is defined as frequency, its unit hertz, or you say that second inverse, and is representing by nu or f. And last one is speed. Last one is speed here. Last one is speed here. Speed means the time rate of change of distance or displacement is defined as speed. That like previous definition that you already learned in first chapter, in that is motion. So speed here, distance, that is in unit time, or you say that in time interval from going to P to Q. Whenever the particle position changes from P to Q, then the time taken, that is capital T, then displacement here lambda, that is wavelength, and time taken, time period lambda upon T is what? That is speed. So in this way you can learn out and try to solve the numerical or some conceptual problem based on this characteristics of wave. If any confusion, then you can ask. So that's all for today. Have a nice day.